discuss about the third generation of the fiber optical communication. In this generation, we are talking about how the generation is utilize their bandwidth according to the requirement. Look at here. The bandwidth used at a 1550 nanometer, but in first generation, if you are talking about, we use a 800 nanometer. In second generation, we use a 1200 to 1300 nanometer. But now in third generation, it is the advancement of a bandwidth utilizations. In that is used as comparison to previously, dispersion was considered very large because the losses in larger bandwidth is larger. If the bandwidth is limited, the utilization of the bandwidth is also limited. But when the generation going first, second and third, after this we going to fourth and fifth, but the third generation is when coming in 1979, the loss of dispersion is very high as comparison to previous two generations. Now we are talking about display more dispersion around 1550 nanometer. We are talking about that wavelength and we are talking about that bandwidth, which is our most precisely or most effectively uses for the communication purpose in optically, basically, where the optical signal is travel very largely. But now look at here, the bandwidth is increased, the losses in terms of more dispersion is increases with the larger amount of that bandwidth. Now dispersion is shifted. Fiber could overcome this dispersion problem, designated to have minimum dispersion around 1550 nanometers. Look at this. The one of the major part and one of the major point at here. The minimum dispersion is located and stopped around the wavelength of 1550 nanometer at here. In this generation, we use that particular wavelength for the transmission of a signal from the source to destination with the help of this 1550 nanometer in between the source and destination. In 1990, commercially available system will use operating at 2.5 gigabits per second and capable to operating at 10 gigabits per second. DSF with signal longitudinal mode lasers. The laser is used for an optical source. At that time, the bandwidth or the signal transmission capacity is increased 4 times up to 2.5 gigabits to 10 gigabits. The amount of the signal transmission in the previously only 1 Gbps. It is the time to improve 2.5 times as an input and 10 times as an output for transmission of the signal. So third generation is the more advanced generation as comparison to the previous two generations. Look at here, the repeaters spacing is around 60 to 70 kilometer, but in the first generation we use a 15 kilometer, in second generation we use a 40 to 50 kilometer. But look at here, the repeater spacing is around to increase 60 to 70 kilometer. It means the third generation is more beneficially utilized for the longer distance transmission of data in terms of optically with the help of this generation. So this is most widely used generation at that time in the duration of 1979 to 1990. Now we are talking about the next generation, about the fourth generation of optical communication used for that. The fourth generation is overcome the drawback or overcome the previous generation drawbacks and improve into the next one generation. The drawback of third generation is a 1.55 micrometer is the signal is regenerated periodically by using electronic repeater. 1550 nanometer we use electronic repeaters for the transmission of a signal duration with a particular 60 to 70 kilometer. But now in that generation, what more advancement is to be coming and we go for amplifiers. Look at this. The fourth generation make a use of an optical amplifier in 1989 and 1990. At that time, the signal is to be improved 10 times, 20 times. It up to you what kind of a signal you want to transfer and what kind of information you share from the source to destination without any lag with the help of that amplifier. We use 3 types of optical amplifier in the communication, optical fiber communication. The one is semiconductor optical amplifier. Now second one is a Raman amplifier and third one is EDF amplifier, erbium dot fiber amplifier. And these amplifier is remove all the repeater spacing connectivity between the distances. It is used up to the third generation 60 to 70 kilometer, which does not require any repeater signal. because it repeats the signal, and after repeating the signal, the same signal is distorted. We use different kind of filters and all these things. At that moment, in the fourth generation, we use the amplifier to enhance the gain, to enhance the signal strength according to your requirement when the amplifier come into that state. And 1989, increasing the repeater spacing and WDM for increasing the bit rate, because higher bit, higher data, higher chances of losses signal, but with the help of amplifier we reduce the signals. So that's the beauty of the communication gap, communication increasing day by day. So these generations will improve every time their own replica is to be improved into the next generations. If we are talking about mobile generation, when nowadays the 5G is coming in my mobiles, but in future, in the next coming years, we're going to a 6th generation of the mobile communication, and that is a more enhanced version of a mobile communication. But same here, optical communication is enhanced version, enhancement of the signals which will improve into the 4th generation. It is used in this. Look at this. Erbium doped fiber amplifier in 1990 using a 62 kilometer apart. Our only amplifier, a single amplifier is required at that duration to amplify our signal without any distortion. So that's the beauty of the optical communication. It is not required a repeater at the time of 1990. Before this, the third generation, we use a repeater, and losses are too much losses. And at that time, the signal is very disturbed at our destination, and the distortion part is too much high. But when the erbium doped is coming, or when the optical amplifier is coming into that generation, lots of signal is to improve, and now there are different kinds of amplifier used for the communication purposes to amplify your signal with using different kind of a modulation for the communication purposes. Several wavelength division multiplying systems were developed across the Atlantic and Pacific Oceans during 1990 and 2001. In response to the internet induced increases in the data traffic, they have increased the total capacity by order of magnitudes. Definitely, when the signal is required higher, when the data is required higher, the some system is to be generated, and at that time we use WDM, wavelength division multiplexing. Means multiple signals you can send simultaneously, and you can achieve your signal when you want. Whenever you want your signal according to your requirement, definitely go for a wavelength division multiplexing. But WDM, it also divided into two parts. First one is CWDM and second one is DWDM. CWDM is known for a coarse wavelength division multiplexing, which means we can only use a 4 to 16 signal at a time only. But when we are talking about dense wavelength division multiplexing, we use a 32 signals simultaneously. So that's a beauty in WDM. If we use a less number of users, we go for a CWDM. If we use a higher number of data rate and a higher number of users for the transmission of a data, definitely we must go on a 32 signals simultaneously with the help of dense wavelength division multiplexing. And optical communication, this is the foremost uses of that technologies. Now, this is to be utilized to increase the internet capacity, to increase the utilization of the different kind of magnitudes. But how we can use? We use a different kinds of modulations for the data transmissions, and that data transmission modulation play a very pivotal role for the transmission of the signal. It's a beauty in 4th generation where the signal is to enhance day to day. After this, we go on a many more milestone in optical communication. We are talking about in next generation also. Look at the 5th generation. This is an advancement of the optical communication. 5th generation, concerned with the finding the fiber dispersion problems. At that time, the 4th generation, the dispersion play a very pivotal role duration of a transmission with the help of optical amplifiers. In this scenario, in this time period, lots of signal is lost. When I send multiple signals simultaneously, it is lost in the optical amplifier. But when this findings appears, we remove optical amplifier problems in fifth generation. Optical amplifiers have solved the loss problems, made the dispersion problem worse. It is itself resolved that problem. It enhanced the problem of a dispersion very efficiently, very effectively, and multiple sources of the signal is to be used simultaneously for the transmission with the help of fifth generation of fiber optical communication. Now, solution is based on the concept of optical solutions, optical pulses that preserve their shape during propagation by counteracting the effect of dispersion through the fiber nonlinearity. It means when the signal is passing on optical fibers, it is very truthful or fruitful according to your requirement without any effective dispersion of the signal during the nonlinearities. So we should avoid such things. We should try to avoid such things duration of a transmission in the fifth generation. So we use a multiple amplifiers, we use a multiple sources of the amplifiers, we use a multiple medium of the signal transmission to avoid the effect of dispersion and many more things. So this is the fifth generation, which is enhancement of a optical communication. Look at this. I'm talking about this, how the generation is day to day increase and day to day enhance the bit rate of the signals. Look at this. In 1974, the 0.8 micron multimode we can be used for the duration of transmission at a time only 10 gigabits per kilometer. But when the ear is going high, the signal is going to be, look at this, optical amplifier, 1 lakh bits data transfer in 1992. But nowadays we transfer 370 terabits per second with the help of optical networks. This is the basic fundamental of optical communication, to transfer a data at that time with the help of a multimode. Means many signal transfer at a time in this. But when with a single mode, it is only 1.3 in the advancement of 1978 and 1980. That is to be increased day by day. But when the optical amplifiers come into the utilization of optical communication, the signal strength is to be very high, and it is going to be very perfectly and effectively with the help of that amplifier, and losses will be reduced almost negligible. But still losses are included on that part, because amplifier is not a perfect source, it is not a perfect medium to travel the signal without any losses. It is also play some kind of a signal losses on duration of that time, but amplifier is overcome the repeater problem during the transmission of a signal. So this is one of the best example for the amplification and transmission of a signal. Now we are talking about the second and third telecommunication windows are further subdivided into the following wavelength band, which are used nowadays. The band, which band we have discussed, which band we can be used as signal for transmission. There is a description, which signal is to be enhanced and it is to be traveled or sending from that part. Now what is the range of a wavelength used on that? First band for the transmission is the O band, and that is the original band which is utilized in 1979 to 1990s, and the wavelength at that time for the first to second generation we use 1260 to 1360 nanometers. But now the advancement is too high and the bandwidth is also too high for the transmission of the signals. The second one is E band. Original, it is little bit extended because the range of the signal is to be enhanced and the information is going very wide and very fast and extended from one area to other and very effectively. So the E band is going to the bandwidth utilized at that time 1360 nanometer to 1460 nanometer. It means the signal strength is very strong and very effective duration of that period. Means the signal is going very high and very efficiently at that time period of a second generations. Now S band is going to be short wavelength band. The band of frequency is 1460 to 1530 nanometer. This is the mid of 2000 and 2005, where the signal strength is to be very high and the signal is effectively utilized on that part. And that duration, the signal efficient and effectively used in this. We can be sent video, voice, audio, any kind of a signal with a multiple users. But when in 1990 is coming and the day is to be enhanced day by day, C band is coming, and that is known as conventional band and RPM window. At that time, we use an optical amplifier, and the range of optical amplifiers duration of that period is 1530 nanometer to 1565 nanometer, and the window is very wide as comparison to the other mechanism, other windows. So that time we can be use larger amount of data simultaneously. After the advancement of this, we go for the L band. A low wavelength is used, and the wavelength speed and data is 1565 to 1625 nanometer. The range is enhanced, data is enhanced, and data is to be traveled very effectively and very efficiently in that bandwidth. Nowadays, in 2024, we use an ultra low wavelength for all kind of signals with the help of different optical network, passive optical network, active optical network, and the bandwidth is used, a wavelength is used 1625 to 1600. This is the right now the scenario is used in optical network for the transmission of a signal is a huge amount utilize the wavelength 1625 to 1675. So now we are coming to the next slide. This is the basic module of optical communication which explain how the signal is to be traveled. The one is transmitter known as a source, that is a medium, or that is a destination. Depend upon transmitter, receiver, everything is to be up to you. Before transmitter, before that source, I will tell you the signal is converted electrical to optical. Electrical to optical. Electrical to optical. How we convert the data? We use some kind of optical sources like LED, light emitting diode, that is convert the electrical signal into optical signals. It means it convert a current into a light signal which is directly going to that transmitter. Other source is laser. Wonderful example of an optical source. Light amplified spontaneous emission of radiations. Longer distance light can be used with the help of a laser, which is used as an optical source. Now we are talking about the medium. What kind of a medium I can use for the transmission? We used a fiber cable. Fiber cable. And that cable, and we are talking about that thing, in that cable we used two things. One is, I will tell you, one is core, and second one is cladding. One is core, another one is cladding. Both are very important and very efficient. If core is lag or cladding is lag, the signal will not be passed. So this is a source where the connector connect and the signal is coming and passing on that part. After this optical fiber connected, the signal is passing like that. The connector is connected to the receiver, and the receiving end we used optical detector, and that optical detector is photodiode. Photodiode. And photodiode means it convert the electrical signal, it connect the optical signal into an electrical form. It means light is coming and output is electrical signal. So at the end, the signal will be reached at a destination, and the destination we use are multiple sources. Multiple sources like PIN diode for the photodetectors. We can be used at here. So this is a basic block diagram, basic working of optical fiber communications. Means you can convert the signal electrical to optical, then optical signal convert that signal into a optical wavelength which you required in the communication. After certain time periods, you can convert that into a core and cladding medium which is passing from that, and the layer is jacketing is also used for the fiber where the signal is not dispersed or not going outside that. In that medium we use a certain phenomena, different kind of a law with different kind of a principles for the transmission of a signal. And in the end, again we require a detector because the signal is converted optical and optical to electrical, and then easy to understand electrical signal. At that time we use a photodiode, avalanche diode, PIN diode, and multi-diode which can be used to convert an optical signal into an electrical. And last, the destination, you receive your signal which is you send into an original form and get into again an original form. So this is a basic. Now we are going to the next part of the two types of modulation. The two types of a modulation. One is digital, second one analog. What is the meaning of a modulation? Modulation means you can enhance your signal with some other signal sources with effectively, perfectly and efficiently without losing any sources, without losing any information. With this modulation, we are talking about two different types. One digital, one is analog. Then we use a carrier sources. In carrier sources, meaning we use different things. The first thing is LED laser diode. This source is basically optical source. This is basically optical source. Why I am talking about optical source? Why the purpose is used to talking about optical source? Because the communication is used at here is optically, and the optical communication means sources is also optically, means the signal is in the form of a light which is travel. How? With the help of an optical source. And what kind of sources we use? Two different type of sources. At here, the four signal transmission. One is LED and another one is a laser diode. LED means light emitting diode. When current passing, the light is emitted, and the principle of LED is electroluminance, and that electroluminance means your signal will be travel in the form of a light, not in form of a current. So that's why in optical sources we use LED. And then the second optical source or carrier source use a laser diode. Laser diode is again a source which can be used to convert a electrical signal into a laser optical signal format. So this is the beauty of the optical communication, where we can be used multiple sources to transfer of information in terms of a light. And many times it will be used in longer distances, maybe thousands kilometers. The LAN wires are connected with that medium with the help of this. The seven oceans and many countries are connecting together with the help of transmission of optical light. Nowadays, our data will be travel is terabits, and it is a very huge amount of data transmission, but source is required, and the LED laser is the basic sources of optical communication for the transmission of the signals. Now, coming for the next part, intensity modulation, it should be emphasized that the information being transmitted is contained in the variation of the optic path. Very good point, because it is explained what intensity the signal is travel, what power you required for transferring the signal, what capacity you think the signal is to be traveled from one side to other side. So this is the intensity modulation, which explore how efficiently and how effectively we should send the signal without any distortion, without any noise. So intensity of the signal is also important for the transmission of the signal. Now the second and the third part is, the output part of a light emitter is always positive. Remain that thing. When we are talking about signal transmission, this is play a very important role for the transmission. The signal is emitted in the form of a light very effectively. It is not going for that signal, it means you lost your signal and never find your signal efficiently. Now we are talking about channel coupler. Fiber acceptance cone required, important, because if the acceptance angle is not perfectly utilized, it means your signal is lost, and that is used angle 90 degree. 0 to 90 degrees means the signal is going to be acceptance region, the signal is 0 to 90 degree, then it is perfectly passing on that part. Now next one is information channel. Low attenuation, large acceptance cone. Low attenuation means minimum to minimum signal is to be reached on that part and going to perfectly with a larger acceptance area. So that is the meaning, which is showing that how effectively the data will be sent and data will be going on to the next part. Now next one is repeater can be used only for digital system. Repeater, matlab your signal is to be repeated after a certain distance, approximately we use 60 to 70 kilometers and certain range of that repeaters. But after certain time period, you cannot use the such things. So this is the basic carrier sources, channel coupler for the communication of the optical, where the signal is to be transferred, processed, exhibit, and information will be shared with the help of optical communication. Now we are talking about next how the detector will work. There are different kinds of a detector we use. We use a detector for the receiving the optical signal. Semiconductor photodiodes. Various designs are most commonly used. Nowadays, you can use multiple medium, you can use multiple sources of optical communication for the transmission of a data and enhance the capacity of a signal and terabits and very huge amount of data share at the click of a button. That is the beauty of amplification of the optical communication, and this is a part of optical communication for detector, because it detects the amount of data and capture the data and enhance the data effectively and efficiently. And we use multiple sources and multiple detectors for the transmission of the data. That is a beautiful things perfectly utilized for the detection of a data. Now we are talking about signal processor. Amplification and filtering is required because when we are talking about amplification of some kind of a signal, so you must know that which signal is amplified and which data is to be amplified on that part. It means you can use signal processor for the amplification and filtering processing. So I think we can cover up lots of things about the optical communication, and this is my second lecture for the fiber optical communication. Tomorrow will we meet again for the third lecture. Thank you and Jai Hind.